Okay, so we're going to talk about conditional probabilities. And I'm going to remind you that if we have two probabilities that are dependent and we want to know the probability of both things occurring, this and that, this is the formula that we get. If the two probabilities are dependent. If we rearrange this equation, if we divide both sides by the probability of A, we come up with this formula. Probability of B given A equals the probability of A and B divided by the probability of A. And we're going to use this as the base, this idea, this guy right here, B, the probability of B given A, we're going to call that the conditional probability. I'm just going to abbreviate to get that done real quick. So that's what this guy is right there. Okay, this guy is a conditional probability. Okay, so we're going to first look at calculating it using when we're given information in a table. So we're going to try to answer these two questions down here using this table over here. So there's a quality control inspector and they check for defective parts. It turns out that that even though, let's see, the table shows the results of the inspector's work. They're asking us find the probability that a defective part passes the inspection. So what they're saying is that when you have a quality control inspector, just because he says that a part passes doesn't mean that it's good. Occasionally they make mistakes, and vice versa. If you have a part that's perfectly good, sometimes they'll say they're bad. Okay, it just happens. It's the nature of manufacturing, or really any kind of business. So anyways, we do get these sort of results. So what we're going to start with is calculate the probability that a defective part passes. So what the deal is we're saying given that the part is defective, give the probability that it passes. So what ends up happening is, to do the math here, we're really looking at this part of the table. See, since we're told that it's a defective part, that means that we're given that it's defective. So it's going to be one of these 39 parts. And if we want to know the probability that it passes, it's these 3 out of the 39. So the way that we calculate this is we will say the probability, well, let's go ahead and just mark this as part A of our question. It's going to be the probability of that it's that the part passes given that it's defective is going to equal, let's see here, the probability of A and B, let's see here, A and B. On top we put the probability of A and B, and in this case A is the probability that it passes and B is, let's see, I'm sorry, B is the probability it passes, A is the probability that it is defective. So the probability that it passes and is defective, that's 3. So we put that number on top. That is this guy right there. And then we put that all over the probability of A that it's defective, and the probability that it's defective is going to be right here. There's going to be 39 ways, so we're going to put that right down there. And so what ends up happening is we then can go ahead and reduce and write this as a decimal or as a percent if we'd like. This will be 1 out of 13, and again we could write that as a decimal or as a percent. Okay. All right, part B is very similar, so I'd like you to give it a try before I show you. You're going to find the probability that a non-defective part fails. Go ahead and pause the video and give it a try. Okay, hopefully you've done some work and hopefully you got the answer. Let's see if I agree. So, probability that it's a part fails given that it's non-defective. There we go. And that will be equal to the probability that it's a non-defective. Let's see, the probability that it fails and it's non-defective. Fails and non-defective. That would be this right there. That'd be 11. And then over the probability of it being A, the probability of it being non-defective, that's this right here. That'll be 461. By the way, a couple little mistakes I'd like to correct here. I don't know why I wrote approximately 1 over 13. If the probability is 3 over 39, it's exactly equal to 1 over 13. The other thing is I keep saying that I've been saying that this is the probability of A and B, this 3, and this is the probability of A, 39. But I also said earlier that probability is always a number between 0 and 1. This 3 is really the number of ways that event A and B can occur, and this 39 is the number of ways that event A can occur, and we can put them together to make this conditional probability. And again, same thing down here. 11's not a probability. It's the number of ways that A and B can occur. You can see again, one of these is A and one of these is B, and the number of ways that both can occur together is 11. So that's what we put on top here. Now, we will do some math where we actually take the probability of A and B and divide it by the probability of A, but this gets us a similar result, and this result is absolutely legitimate.